Okay, so just the plain sine function, we are looking at y equals sine of x. Okay. So let's think really briefly about values from the unit circle that would make graphing this really, really easy. Remember, you can graph anything by using a table, by plugging in values. So the sine of 0 is 0. So sine of x goes through the origin. The next easiest point to use would be at pi over 2. Sine of pi over 2 is 1. So if you can't see it very clearly there on your graph, pi over 2 is the next line that's marked there. Sine of pi, we're back at 0. Sine of 3 pi over 2, we're at -1. Sine of 2 pi, we're back at 0. If we talk about negative angles, sine of negative pi over 2, negative pi over 2 is the same as 3 pi over 2. So its value is -1. Negative pi is the same as positive pi, so it's at 0. Negative 3 pi over 2 is the same as positive pi over 2, so it's at 1. And negative 2 pi is, of course, the same as positive 2 pi, so it's back at 0. Now, we could plug in some more specifics, but if we take these points and our background knowledge that we have of these graphs, then we do know that it looks somewhat like this. Do not connect those with straight lines. It is a curve, so make them as really circular as you possibly can, because that's truly what this is. If I had this to the right scale, it's kind of like you're unrolling the unit circle to produce this graph, so kind of a different idea there, but that is essentially what's going on. Now, amplitude and period, that is something that we need to discuss. So if we look at that, we're talking y equals a times the sine of bx. A times the sine of bx. We can use x and theta interchangeably. So the amplitude, if you recall, that is the height of the function. So what we're talking about, though, it's not bottom to top, it's from the middle to the top, or from the middle to the bottom. So in this case, the middle is the x-axis, so the amplitude would be 1 unit pi. The standard amplitude is 1, and we discussed that in Math 3. We also discussed the standard period. The standard period is 2 pi. Now, how is that shown on the graph? That's the length of one cycle. So I can start at any point that I want to on this graph. So I'm just going to start over here at -2 pi. Okay, and if I wait for that to cycle all the way through and get back to its starting point, it gets back to its starting point there at 0. So the length of that from -2 pi to 0 is 2 pi. I could have also looked at it from this minimum point right here at -pi/2. If it goes all the way through the cycle and returns back to that same point, then that's going to be at 3 pi/2. So from -pi/2 to 3 pi/2, that's still a length of 2 pi. So it doesn't matter where you start or where you stop on this, the cycle length is still the same. So a period is the length of one cycle. Okay, now this should be something that we're able to tell from the equation. So that example there on the right side, we have 4 sine of 1/2 theta. So the amplitude is the coefficient in front of the trig function. So the amplitude here is 4. The period is 2 pi divided by b. The period is 2 pi divided by b. So in this case, b is 1/2, so 2 pi divided by 1/2 is the same as multiplying 2 pi by 2. So the period of this is 4 pi. Let's go back and just apply our general transformation rules to this. If we are multiplying our x, in this case x is theta, if we're multiplying our x by a constant, it's either a horizontal stretch or it's a horizontal shrink. Any of our horizontal changes are the opposite of what we expect. So if we're multiplying by 1/2, we expect that to shrink, but it's the opposite, so it's actually going to stretch. It took our normal period of 2 pi and it has stretched it out to 4 pi. So if we're graphing this by hand, which I've realized we can use our calculator, but let's just talk about this for a second. It's still going to go through the origin, okay? It's still going to go through the origin, but it's going to take all of your x values and it's going to multiply them by 2. So before, at pi over 2, we hit our maximum. Well, that's not going to happen at pi over 2. Now it's going to happen at pi, because it multiplies that by 2. So it's going to happen at pi, and the maximum is no longer 1. Our amplitude is 4, so at pi, our maximum value is at 4. Normally, we cross the x-axis at pi. We multiply that by a factor of 2. So at 2 pi, we're going to cross the x-axis. If we go in the negative direction, our minimum was at negative pi over 2. So we multiply that by a factor of 2. Our minimum is going to be at negative pi, and it's going to be at negative 4 because of our amplitude. And then we would get back to the x-axis at negative pi. So multiply that by a factor of 2. That's going to be negative 2 pi. So you can see how your graph, there are actually 2 stretches going on here. We've got a horizontal stretch and we have a vertical stretch. And it doesn't stop there. I kind of made a mistake. I kind of ended my graph there on the original. But y'all know that this pattern continues on for forever. We call these periodic functions because they have this same cycle that just keeps repeating infinitely in both directions. So yes, it ends in the window that we're looking at, but it doesn't really end in reality. Okay, any questions about those? Cosine is pretty much exactly the same. Think about your relationship between sine and cosine. Pretty much the values are just kind of flip-flopped a little bit. At 0, the value of cosine is 1. At pi over 2, the value of cosine is 0. At pi, we're at negative 1. At 3 pi over 2, we're back at 0. At 2 pi, we're back to 1. And then we just have the mirror image of that on the left side. If you recall, when we discussed even and odd functions, we talked about the fact that sine was odd and that cosine was even. So remember what one of those properties is. If it is even, then it's symmetric about the y-axis, and we can see that here with our cosine function. With the sine function, again, that rotational symmetry is a little bit harder to see, but it's still there. Okay, so cosine is going to be the same deal. We've got y is equal to a times the cosine of bx or b theta. Those are interchangeable. The amplitude is still 1. It just happens in a different place, but the height of that function is still the same. The period, let's look at the period here. I don't know, my eye is drawn to this point right here in the middle. If I cycle all the way through and get back to that point, that goes from 0 to 2 pi, so obviously that distance is 2 pi, so the standard period here is still 2 pi.